And the last thing I want to talk about in just the last 2 minutes here is availability. So the way I've solved availability is I've put multiple servers in different places. So you kill any one of the servers, everything's okay. In particular, you kill any one of the 13 root servers, not a problem. There's 12 more to take its place. I distribute the servers widely, so any particular network fault won't kill me. I tolerate configuration errors because I work as long as one of the servers at the parent matches to the actual thing at the child. As long as one of those works, it's fine. But of course, when you look at the tree structure from a security point of view, there's this glaring thing at the top here, where 13 servers. Take those out, you have a very disproportional attack. You've just killed the entire system. But actually, I'm going to claim that's not a problem. The one I'm worried about here is this middle guy, the comm servers, because he's got 30 million zones below it. And that's where I'm going to get in trouble. Purdue has 5 servers, and yes, in fact, I can take out anything if I do enough DDoS. But the bugaboo always in DNS is, oh, I'm going to kill the DNS servers. We don't care. Kill the DNS servers, doesn't matter. The DNS servers point you to, at most, 300 zones. The common codes, com, edu, net, org, etc., plus 200 some country codes. That information is also well published, well known, it's easy to obtain. In fact, my resolver already knows how to get to com, edu, net, org. That's probably the first thing it figures out when it wakes up. If you DDoS, yeah, I might get unlucky that my entry for com expired right as the DDoS started, or while the DDoS continues. But even if that unlikely event happens, I can always go find this information from relatively easy static public databases. I can replicate the root zone a lot of places. In fact, this is done. If you go to any operations center of major ISP, there's actually a static configuration for the root zones that can be plopped in case any of the root servers are taken out. It's a fine target to shoot at. You know, it'll make the Washington Post when you kill 9 out of them, but it won't actually damage the internet in any meaningful way. Blow away com or org or net, you've done some damage. Because unlike root, where there's 300 people sitting below me, there's 30 million sitting below com. And the chance that I've cached all those, or I can easily go look up all those, is not a trivial problem. So it's the com that's the real one. And this is where a lot of activity in both the operations and research community is. The research community has taken attack of distributed hash tables. And you can look at the recent SIGCOMM. There's an entire section in SIGCOMM 2004 dealing with this kind of approach that says, let's throw away this whole structure. Let's apply a DHT. The DHT will tell us what the servers are. Now I have a proportional attack. You take out some servers, you take out some zones, but there's no central root authority at the top. But this actually isn't going to work. And the reason it's not going to work follows some of the reasoning for DNSSEC. It's a great, simple idea. I mean, if I tell you I'm going to put public key crypto into the DNS, I mean, you're going to think that's an undergrad course project at the best. It's not that hard. Similarly, DHTs, when you throw away the complexity of the real distributed system, it's not that hard. Now the DHTs are trying to deal with the problem of Google actually wants to control where their servers are. And other people don't want to randomly wind up with Google. Right? So not all servers are equal. How do I control this thing? What we have in the end is DNSSEC. So this would be my... So where are we going to go in the future? What we have at this stage is we have DNSSEC that works for the most part with some nice open problems. Key revocation, and some of the other issues we discussed. But this isn't going to be enough to motivate deployment. What it really does is it enables us to look at other cool features like DHTs. Those DHT papers immediately assume DNSSEC. Because once I have DNSSEC, I can say, the actual server doesn't matter anymore. I have a credential I can verify, so now I've got a lot more power. With that power, I don't think you need to go to DHTs. If you want to be simply operational, we've actually got some studies that show if you simply increase the TTL on the name servers, not the records, which change a lot, but the name servers, which change rarely, you will not create any black holes due to changing records. Yet if you DDoS the comm servers for a long period of time, weeks, you will lose only 3% of your queries, because queries actually tend to be fairly localized, and with long caches, you can keep these in your database. So now, instead of trying to solve this massive DDoS problem, I've got to figure out how to get the remaining 3%. But they're out there somewhere, even though I can't get to comms. Some cache has them, or somebody has them. So the open problem in DNS right now is to take the fact we have crypto and now consider the more serious problem of denial of service and see what we can do. So if the last thing to take away is just, I think DNSSEC is an interesting technology. It's a nice case study in how to deploy crypto in a simple system. If you want to take it further, say, this is a good tool. How can I use this tool to solve data availability and other problems within the DNS? And there's some room for some interesting research there. So I think I'm over time, but I'll stick around if there are other questions.
Yeah, if there are questions, let's move out in the lobby out here, because we have a class in here right after this one.
Okay.
Thank you.
Thanks.
Hey, I got a fuse.
Oh, really?
I had to run back across campus and put this up, so I missed the first two.